Hi, here we have a train traveled at 1/3 of its usual speed and hence reached the destination 30 minutes after the scheduled time. Okay, so what's happening is speed becomes 1/3. Now we know if the distance is constant, the person has to travel between the same 2 points. So if speed becomes 1/3, time taken will become 3 times. Reciprocal. Speed and time are inversely proportional when distance is constant. Hence time taken will become 3t. That means the difference in time taken is 3t minus t. At usual speed and at a slower speed, if you look at the difference in time taken, that will be 3t minus tt, which is 2t, and basically he gets late by 2t, which is equal to 30 minutes. So this means that his usual time taken was 15 minutes. Usually the person takes 15 minutes to go from his origin or start to the final destination. Now on the return journey, so let's say these are the 2 points A and B. Now on the return journey, what's happening is the train initially traveled at its usual speed for 5 minutes. So at usual speed, it would take a total of 15 minutes to reach A, right? But for the first 5 minutes, he travels at his usual speed of S. But then he stopped for 4 minutes. So at this point, he stopped for 4 minutes. Fine. So the percentage by which the train must now increase its usual speed so as to reach the destination at the scheduled time. So usually if he had not stopped here, if he had traveled at a speed of S, how much time he would have taken? It takes him total 15 minutes, and to travel this part, he has covered this part in 5 minutes. So he would cover the remaining part in 15 minus 5, 10 minutes. This is the usual case. But because he stops for 4 minutes at this point, so now to cover the whole distance within 15 minutes, he would have to cover this distance in how many minutes? 15 minus 5 minus 4, that is 6 minutes. Out of 15 minutes, he has already spent 9 minutes, so he only has 6 minutes left. So instead of 10 minutes, he has to cover this distance now in 6 minutes, right? So now since distance is constant, the person is going from here to here. Since distance is constant, speed and time will be inversely proportional. So speed usual upon speed new will be time new upon time usual. So in this part, if the normal speed is S and let's say new speed is Sn, this is equal to new time. The new time is 6 minutes upon the usual time, which is 10. So this comes out to be 3 by 5. So Sn, the new speed is 5 by 3s. So the new speed should become 5 by 3 times of the normal or the usual speed. Okay, so percentage change in speed will be the new speed, which is 5 by 3s, minus old speed upon old as in usual speed into 100%. Speed instead of s, it should become 5 by 3s, right? So this is the percentage change. So this will come out to be 2 by 3 into 100%. S cancels out. We have 5 by 3 minus 1, which is 2 by 3 into 100%, which comes out to be 66.66% or approximately 67%. Hence option C here is the right answer. We have to give an answer which is nearest to. So 66.66% is nearest to 67% out of the given options.